Through of what Stu Schwartz did on this front page, and you can find this on the internet. If you have a quantity, it's an exponential growth or decay equation. If you have a quantity that's growing or decaying in proportion or in the same, how did they word this? Directly proportional to the current amount, the population or tire pressure or whatever. Here's your differential equation. And then to solve it, and I'm hoping that you see is you don't have to solve it this way every time, that you can jump right to the shortcut if it's this kind of problem. So what we're going to do is separate the variables, and this is all I'm doing is walking through what he did on this worksheet. So I'm bring the divide by p to get it with the dp, I'm going to multiply by dt to get it over with a k, and then I'm going to take the antiderivative of this side, which gives me the natural log of p, equals k times t plus some constant. Now I want to get rid of the ln, so I'm going to exponentiate both sides. And of course, this is what you've been doing right along here. So the ln and the e cancel out, so I'm left with p. And then what you've got to remember is e to the kt times e to the c is the same thing as this expression here, right? When you're adding and multiply, you add exponents, you multiply on like bases, and then as you've seen before, e to the c will just write as some initial value a. So that's the solution to that differential equation. So when they say write the differential equation, you write this, and then just the general solution will be this, and then they're going to tell us some specific values, and we're going to find a, find k. It depends. Okay, so let's go do the next question. So what I'm saying is, hopefully you don't have to walk through this process ever again. So for this problem, they're telling us that as air leaks out of the tire, the rate of change of air pressure is directly proportional to the current pressure. So the differential equation is the pressure, the change in pressure, and with respect to time is the same as some constant times the current pressure. And if you think about this, how a tire deflates, if you poke a hole in it, air rushes out quickly, and then as there's less and less air and less pressure, the rate at which it's coming out is slowing down. So that's one way to think about this. So then we know the solution to this general solution to this differential equation is in the form p equals ae to the kt. Thinking about that work we just did. Now, what's a little weird about this problem that he gave us is he's telling us that the initial pressure is 45 pounds per square inch. So we can do that. That's not the weird part. But then they're telling us at the time zero, it's losing air at 36 pounds per square inch. Now, notice this is a rate. And the only way this isn't a quantity, the pressure, that's a rate because it's at a time. So the way I did this is I took the derivative of this p function. So that's dp dt equals 45. Remember, the derivative of e to the kt will be k times e to the kt. So 45k e to the kt. And then I used this 36. Now the 0.36, I know it's negative, so I said negative 0.36 equals 45 times k, and then at time equals 0, right? If time equals 0, that becomes 0. E to the 0 is 1, so we don't have to worry about that part. So to find the k in this problem, we're going to divide both sides by 45. When I did this earlier, I got k equals negative 0.008. So the solution is going to be y equals 45 times e to the negative 0.008t. So that's all part A. So then to answer part B, they're asking me what's the pressure going to be 10 minutes later. So I just realized I wrote y here, and I probably want to be writing p. So that's p of 10. So 45 times e to the 10 times negative 0.08 is negative 0.08. So grab your calculator, raise e to that power, times it by 45. I got 41.54 pounds per square inch. Then for C, how long before it's safe to drive? So you're going to say, hey, the pressure's 20. I've got 45 e to the negative 0.008 t. Divide by 45, take the natural log, divide by negative 0.008. I got t equals about 101 minutes. So for this problem, they're telling us bacteria grows in a way so that the instantaneous rate of change, the derivative, is directly proportional to the number of bacteria present. So write and solve the differential equations. Well, the differential equation is dp over dt equals kp. Then the general solution is going to be p equals a e to the kt, and then they're telling us some information. There's 3 million bacteria initially, so p equals 3 e to the kt. And then they're telling us that 3 hours later, the number had doubled. Now, if you think back to last year, well, I'll write it out the long way. 6 is p, because it's doubled to 6. Doubled to 6. E in the, 3 hours, so 3k. You could just jump to 2 equals e to the 3k, if you think about that, because 6 divided by 3 is 2. Now we're going to take the natural log of both sides, and then we're going to divide that by 3, and I came up with k being equal to 0.231. It's good that it's positive, because this is a growth equation. So y, or p, population equals 3 million times e to the 0.231 t. So that's all our work for A. So then for B, what will it be 1 full day? Well, that's 24 hours. So 3 times e to the 0.231 times 24, that should be a 1, times 24. And when I did this earlier, I came up with 768 million bacteria. How long will it take to grow from 1 billion to 2 billion? Well, they're trying to be tricky. Didn't it double in that time? What's the doubling time? 3 hours. So no math needed there. Why isn't the world inundated with bacteria? Well, they die off faster than they're. Actually, what happens? Better answer is, this is not a straight exponential growth model. Usually what happens is they'll grow exponentially for a while, and then they'll level off. And in Calc 2, you'll learn about logistic regression models or growth models, and that's what this is. So here we go again, another proportional to the current sales. So we can say d sales dt equals ks. Now we're going to solve that, so S equals AE to the KT. And they're telling us there's 5,000 initially in January. So S equals 5,000 times E to the KT. And then in April, which is 4 months later, so we have this 0.47. So 7 equals 5 times E to the 4 times K. We'll divide by 5, take the natural log, then divide by 4, and I came up with a K value of 0.1399. Okay, and then, so the equation will be S equals, let's do it in context, I guess. S equals 5 times e to the 0.1399 t. Okay, so that's part A. For part B, they're asking us how long will it take to go from 10 to 15,000. Well, I said 10,000 equals 5e to the equals, let me erase that, to the 0.1399 t. I divided by 5, divided that, took the natural log, divided by 0.1399, and I got t equals 4.955. And then I said, how long till 15,000? So 15 equals 5 times e to the 0.1399 t again, divided by 5, took the natural log, divided by 0.1399, and I got t equals 7.853. And then how long? Well, here's how long it took to get to 10. Here how long it took to 15,000. Subtract them. 2.898 years. And that kind of makes sense. If the doubling time, because that's what that is about 5 years, and then I wanted to go half as much again, so it's not doubling, because doubling would be 20, so that's a little longer than half. And remember, because with this growth curve, it's going to take longer to go from 2, from 2 to 3, is not quite half. It's a little, well, it's half numerically, but because it's growing, it's not going to be quite half the time. It's going to have to be a little bit more time. Because if you invest your money in a savings account, right, the time it's going to grow the most is that last year, right? It's part of that exponential growth. So last question, we know it's a half-life problem. I also, if you think back to last year, they didn't ask us to write a differential equation. So I'm going to write 1/2 equals e to the k times, let's see, the half-life is 24,360. So that's the equation I'm going to solve. I'm going to take the natural log. I'll divide that answer by the 24,360. I came up with a k value of negative 0.00002845. And then I start with 8 grams, and I want to know when is that 8 grams equal to 1 gram. So 8 raised to the negative e to the 0.000284 t, divide by 8, take the natural log, divide by that god-awful number, you get a big fat 73,080 years if you do some rounding. Long time. So hopefully you guys will develop some non-radioactive kind of energy source.